So welcome to Apply Force at Location in Action. What we're going to do in this video is actually start applying some forces to the tank. And what will happen is if we were to turn off gravity on the tanks, at least, then you would see that once we've finished, our floating tank, when we accelerate, does actually start to move. The reason we're not going to get it moving on the ground is because in the next lecture after this one, we'll be dealing with friction and overcoming friction. So I'll see you in there. I can feel the anticipation building for this lecture because the tank is going to move in this lecture one way or another under our control. So firstly, so that I don't have to connect my gamepad every time, I'm just going to go to the project settings, input, and then under these axis bindings for the gamepad left trigger axis, I'm going to add an alternative input, which is just going to be the left arrow. So not the gamepad, but the left keyboard arrow. And I'll do the same on the right track. Just search for right, collapse gamepad, right. Perfect. And these things, of course, will send just a value of 1 or 0. You won't be able to go backwards on the track, and you won't be able to control it in an analog way, but it'll allow me to just use the cursor keys if I want to. Fantastic. So let's go in and just check that those reports work. Yep. Looking in the console, that's all fine. Great. So it's time to start thinking about actually applying a force to this tank. So one of the first things we're going to want over in our code is the notion of a max force variable, or something like a track max driving force. So that would be a float, because a float is big enough to store pretty large numbers, billions, and we don't want to constrain ourselves to integers. So float, I don't know, track max driving force equals, now we need some sensible default value, and we're also going to make it a U property. Let me do the U property thing now. So it's going to be a U property so the designer can tweak this in the inspector, but we still need a sensible default value. So it's going to be a U property. Now, what is its class of U property going to be? It's going to be edit defaults only, because we don't want to be able to change this on individual instances. We want all the tanks to be the same, right? We want it to be fair. So we have an edit defaults only U property. The question is, what is a sensible starting max driving force for the tank? Bearing in mind, by the way, that we're actually going to have two driving centers, what we're going to do, if we look at the tank blueprint in the viewport, is we're going to realize that these two tracks have their pivot points down here at the bottom in the middle of them, this one and this one. And what we're going to do is we're going to apply a forward force to the tank body, this element here, but we're going to apply that force at the position of the track's origins, which is just about right, because that is in the middle of the tracks. So that'll work pretty well. All right, so we're going to have two separate tracks, but let's not worry about a power of 2 at the moment, i.e. whether we're going to have, however many newtons of force or twice that many or half that many. I'm not worried about that. I'm worried about the order of magnitude for the moment, the factor of 10 amount of force we're going to need to accelerate a tank at a reasonable pace. And that's what we're going to put in here, in the track max driving force in newtons. So let's put a comment on here. This is max force per track in newtons. Okay, great. So what I want you to do is see if you can work out what a sensible default would be for this. Now, I'm going to give you a few hints. Remember that force is mass times acceleration, good old Newton. Be clear on what units we're using here. So as a hint, you need to use SI units for everything for this to work properly. So your force will be in newtons, your mass is in kilograms, your acceleration is in meters per second per second. Guess an initial force, assuming there's no friction in the world. There actually is some friction, but let's assume there's none for the moment. Don't be too alarmed if your tank doesn't, well, we're not putting forces in. I just want you to get an initial value. So assume there's no friction stopping the tank moving. Imagine that it's frictionless. And let's try and get within a factor of 10 of my guess. So I want you to work out what the acceleration of the tank, a sensible acceleration of the tank would be. So to help you with a sensible acceleration for a tank, I've got a link here in the lecture resources, which goes to Wolfram Alpha and says, well, what's 0 to 60 miles per hour in 10 seconds, which is roughly what a fast tank might do it in. And it says it is, in the appropriate units, 2.7 meters per second per second. Well, you could call it 10 in a game, perhaps, because things tend to happen faster in games. So that's what I want you to do. I want you to have a go, see if you can work out in newtons what a sensible force would be. As I say, if you get within a factor of 10 of my guess, that's cool with me. Okay, welcome back. So my solution goes something like this. The tank weighs about 40,000 kilos. Let's just go and see where you find that information. You look on the tank here. It's the only part of the tank that's got physics enabled on it, and it's got a mass in kilos of 40,000. Fine. So force is mass times acceleration. Imagine 10 meters per second, 1 g of acceleration. Okay, that's a lot for a tank, but they're pretty fast. And in a game, you generally tend to expect things to move a little bit faster than in real life, or they just look too slow. So that gives you a force of 400,000 newtons. So let's go ahead and try that as a default value. 400,000, and then I'm going to put a comment in as to why. We're going to assume tank, or 40-ton tank, and 1 g acceleration. If I can spell acceleration, I think I've got too many C's or E's or L's or something in there, but that's fine. Okay, so the tank max driving force is set there. So then we've got that available over here to use, which is going to be really important. So how are we actually going to apply the appropriate force to this tank? That's the next question. Well, let's start building it up. Let's use autos because I like the flexibility and how little you have to worry about what the type is. Of course, you can still get the type by hovering over the variable in question. So we're going to have a force applied, and that's going to be a vector. And if you think what the force applied is, it's going to be the forward vector to a start. So if we just get the forward vector of what, you might ask, of the track, right? So we look in here, and you look at the track, and its forward vector is along the x, the same as the tank. You multiply that forward vector by what? By the throttle. Okay, well that's fine, but now we need to multiply it by this tank max driving force, or track max driving force, whatever we called it. Perfect. So now if the throttle is 0, you get no force. If the throttle is 1, you get the max driving force. If the throttle is -1, you get backwards force. So that sounds about right to me. So now we need to think about the location that we're going to apply the force. So auto, force location, and it turns out you can just use get component location. Now, what's that going to return? Well, if I could spell force properly, I would hope it would return an F vector. What is that F vector? It is going to be the location of the tracks. Now, my tank is upside down for some slightly bizarre reason. What's gone on here? Okay, just a few undos. So what I was saying is that the track location is there. That's what I was talking about. So that is the component location of the track in question. Finally, what we've got to be able to do is add a force to something. And what we want to add a force to is this guy here. This tank root component is a static mesh. How do I know it's the root component? Because if I try and replace it with something else, you can see drop here to make left track the new root. So the question is, how do I get this root component? Well, there are several ways you could navigate to the root component, but let's think about it this way. Let's start by saying, well, let's use an auto so that we know what we're getting back. And let's call this thing tank root. Okay, which is just this guy here. So let's try and find this tank root. Well, let's imagine firstly that we just get owner. What do we have if we get owner? What type do we get back? We get an actor. It's this guy up here. It is the tank itself. Okay, so that is the owner of the track. Well, we need to go further than getting the owner. We need to get the root component from the owner. So we go up to the owner, then down to the root component. What do we have now? A useScene component pointer, which is this tank here. Okay, remembering that a static mesh component is also a useScene component. Let's have a look at the class hierarchy. So back in here, we see we have the static mesh component, which is what in the tank blueprint we are showing the tank as. But a static mesh component is a mesh component, is a primitive component, is a scene component. So what does this primitive component do? Well, primitive components are scene components that contain or generate some sort of geometry and will be rendered or used as collision data. So we want to use the simplest thing possible. It turns out that a scene component, this tank root, which is what we've got at the moment, does not allow us to add any forces. How about if we cast that down to a primitive component? Will that allow us to add forces? Well, let's find out. We're going to do a cast to U primitive component with some brackets. And then now what we get out of the tank root is a U primitive component. Now, when we interrogate that, we can add force at location. So that is the most basic type of object we can use where we can add force at location. So let's recap what we've done because a fair amount's gone on there. We've gone up the class hierarchy to the owner, down to the root component, and then we've cast that from a static mesh to a primitive component, the simplest thing we could go to. And that allows us to add a force at a location. Now, what does that take? What inputs does it take? Well, luckily we've got them. So it takes a force applied as a vector and a force location. And that's it for now. They're all the parameters we need to provide it. Let's see if this works. Let's go ahead and compile up our code. I'll leave the code on the screen while it compiles. Hopefully this stuff makes sense to you. We still need to clamp, so the to-do needs to stay here. We may as well still keep logging the throttles while we're debugging. I'm going to turn my gamepad on, actually, and then we will see if it moves. Now, I wouldn't hold your horses too much because the chances are there's friction in the world that's going to stop this moving, but let's just see how we get. I'm running both throttles flat out, and unfortunately it doesn't move. Now, I wouldn't worry too much. There is a force on there. One way you can tell that is to take the player start point, for example, lift it up. You could turn off gravity on the tank and compile it. Then if we play the game with it up in the air and put full throttle on, you can see it is actually accelerating, and it's rolling back as well because the force is off center compared to the center of mass, but it was accelerating. So the issues that are causing it to not accelerate quite how we want it are due to the fact there's friction in the world. So just before we leave this lecture, I'll show you that problem and then we'll solve it in the next lecture. If I was to take an AI tank, for example, and move it up onto the side of this hill like this, okay, and then play the game, let's look at it. Well, there's no gravity, so we need to put gravity back on, compile the blueprint, and play again. Watch what happens. It lands on the slope, it slides down, but it's got a lot of friction on that tank, okay? And that is what's causing our issues, is the amount of friction. Now, we do want some friction. In fact, the amount I slide sideways, you could argue there's not even enough friction, but it is a subject of another lecture to talk about how we cope with, deal with, and generally organize friction. So, well done. Your tank at least is ready to move. You can see that it's got the force. Now we'll find out how to overcome that friction.